I'm Mark Kavanaugh for Cavi Coaches, and today I'm going to coach you up on solving a problem in projectile motion with a horizontal launch. Today we're going to look at solving a problem with a horizontal launch, 2D kinematics problem. First thing we're going to look at is the steps to solving these problems. So it's important to note that the first step is listing all 6 variables in the vertical direction and horizontal direction. So we have 2 directions. Remember, there are 2 different 1D kinematic problems. Then we're going to draw a diagram of the velocity. If the launch angle is anything other than 0, then we have to use trigonometry to find the initial x and y velocities. Then you're going to set the accelerations equal to 0 in the x direction and negative 9.8 meters per second squared in the y. We learned from the previous video that the x direction is constant and the y direction is in free fall. Then you pull information from the problem to fill in your list. And then most likely you're going to solve for time in either the x or y direction if it's not given. The y direction could be a quadratic, and we'll look at that in the next video. Then you're going to solve for what you're asked to find. Now, a couple tips that at the highest point, the final y velocity is going to be 0. So if it asks about the final height, the y velocity is 0. And means that only has the initial x velocity at the highest point. So that's important information to keep in the back of your mind. So here's the question we're going to look at, the cannonball that we looked at in the previous video, shooting a cannonball off the top of a cliff. The information is given. So what we're going to do is we're going to break down this problem. And what we're looking for is how far from the base of the cliff. Well, that's delta x. And you have to remember that it's important to treat these as 2 separate 1D kinematic problems, which is why the visual portion of what I'm asking you to do is list the x variables on one side of your page and the y variables on the other. And the reason for that is so that you're differentiating them, showing that it's 2 separate one-dimensional kinematic problems. Now we know the information that it's fired horizontally at 50 meters per second. So we're going to draw a velocity diagram. So here's our initial velocity, but it's fired horizontally, so it's not just our initial velocity, it's also our initial x velocity. And because the x velocity is 50 meters per second, that means there's no velocity in the vertical direction because it's shot horizontally. So horizontally, the key is that the initial y velocity is 0. Well, we know that the cliff is 100 meters high. That's the delta y. That's the difference between y0 and y. So 0 is the final because it lands on the ground, and y0 is 100. And we can assume that x0 is 0 since no information is given. Now we can plug in the values for the accelerations. We know that the x direction acceleration is 0, and the y direction is in free fall, so it's negative 9.8 meters per second squared. Then the question is how far from the base of the cliff, so we put the question mark next to x, and the only equation that works in the x direction is this second kinematic equation on the AP Physics 1 formula sheet. So if we look at x is equal to x0, bx0 t plus 1/2 axt squared, that's our equation. The first equation would just tell us the initial velocity equals the final, and the same thing for the third. So we cross out anything that's 0, and we simplify to this equation. The problem that we have to use this equation is that we have 2 unknowns. We don't know x and we don't know t. What we do know is that the time in each of our columns is the same value because that's the flight time of the cannonball. So what we can do is we can use the vertical direction to solve for time first. So using the vertical equation to solve for time means that we don't know the final y velocity if we're looking for time. And not knowing the final y velocity being the second dash means we're going to use our second kinematic equation. Y is equal to y0 plus by0 t, etc. And we can cross out anything that's 0 and rearrange our equation, rewrite our equation. 0 equals y0 plus 1/2 ayt squared. Then, as I've asked you to do in the past, solve for the variable that you're looking for first, which is time. So time is going to equal the square root of 2 times 0 minus y0 divided by ay. Then we can plug our numbers in. 0 minus 100 would give us negative 100, and then we can solve for time. So we can see the units cancel out, meters, leaving us with 1 over inverse second squared. Square root of that gives us seconds, and the value is 4.52 seconds. We can see that 4.52 seconds is not just a flight time in the vertical, but also the horizontal. And now we can go to our horizontal equation and plug in our horizontal velocity times the time, and that horizontal velocity times the time. We see that the seconds cancel out, leaving us with meters, and x is equal to 226 meters, which is how far from the base of the cliff that the cannonball lands. This is solving a kinematic problem for a horizontal launch angle. I hope this was helpful, and I hope you have a great day and an even better tomorrow.
If you found this video helpful, don't forget to click the like button down below and subscribe to my channel, Cavi Coaches, and follow me on Instagram and Twitter @CaviCoaches.